this is the main file you have to work with, and these are types, as I mentioned before, and you have to complete the definition for these outside the class, similar to these functions, methods I have given you. And whenever possible, you should use these functions, invoke them in your code. This is your file on stream. It's on stream, I told you. It's called skeleton.h. You have it available. And there are 3 data members, as you can see here. This create and create overloaded with 2 arguments and copy are private methods. The class, every method in the class can use them, but you can't use create in main because it's not public. So create or create this one, or copy vector, you are not allowed to use them in the main, but you might need to use them in your implementation of constructors or assignment operator, because as you can see here, you have to implement the assignment operator, copy assignment operator, and the move assignment operator. You have to implement copy constructor and move constructor. And we talked about this when we talked about dynamic memory allocation. You have good examples with the array type class, or so you have to write code for this. For index operator, which comes in non-constant and constant version, you have to implement them. And then they don't require a lot of information. It's good to try to make some checks that I is less than the size and display some messages. This is not the case. You don't have to implement exceptions for this type. If you do, that's fine. You can trigger exceptions, that's okay, but it's not a requirement. I wanted just a simple way of dealing with this type, which for some people is quite complex as it is. So you can assert that I is less than size, and then you put a quote, assert I less than m size, and performs the operation. So implementations for this, then you have push back method, which requires some explanations. Erase is one element, the one to which P points, and then returns this P pointing to the shifted element, as I mentioned yesterday. Resize, good commenting, and clear means set the vector to 0. Be aware that you shouldn't have memory leaks for clear. Empty, just check for size 0. So if the size is 0, it means that your vector is empty. Otherwise, it's not empty. Size is just returning the number of current elements in the vector, in other words, n size. So some of these functions are quite simple, one statement or 2 or 3 the most. Begin, it's just returning the pointer to the beginning of m data. Return m data, it does the job. So it's again one simple thing. Return the end, you have to look at m data plus the size. And this will take you to the first element outside the vector. So another one element. And constant, you have the same code, but because you put it constant, then it can be used with constant vector objects. So be aware, in order to test these constant methods in the main function, you might want to, don't know whether I have added a constant vector. It would be good to say constant vector v1 after you test other things, and then call your index operator. So it's your responsibility to check all your method in the class. I have put code for some of them, but I haven't put for constant, so you can have fun. As you can see here, add more test cases. It's your responsibility to test every method in your class, and we will try to do some testing as much as possible. Any questions, please? For your assignment, any questions? So you have this file, you don't send this file, you just send this file after you fill in the missing places, missing methods. Once again, you have to work only this part, and then everything in this part. Don't change anything inside the class if possible, and this will be possible. You might change it, but if there are no good reason for change, you might get some problems in marking. So if there are any questions, ask by email, preferable before Sunday morning, and ask in the lab, ask now to. So it's not much time left, but I have talked about this for a while. Any questions? Right. There. And I will put up the optional assignment as next week we will cover the material. Yeah. We have started talking about Java. By now, hopefully you have installed Java GDK on your computer and you can work with that. We covered primitive and types and reference types, operator strings, and we briefly looked at the array, and we have seen that array in Java are reference types, and they have to be declared using new. They can have different size when you are working with rectangular arrays. Because they are reference types, in other words, implemented with classes, they come with a lot of facilities. One facility is member data, a field, which gives you the number of elements. So this is not a function, this is a member field. It's very efficient to invoke it like this. So the name of the variable is array, and it's a float of 10 elements, and whenever we do something, after we initialize them, the elements, then we can work and display them. If we don't initialize them, as I mentioned before, they are initialized by the default values for the type. For primitive types, they are for floats 0.0 and so on. For reference types, null is the default value. Be aware, null. So you don't print those. Because of having this extra information coming from classes, Java is able to check that we don't have silly mistakes. And their way to let us know that things are wrong appears at runtime with exceptions. And we have seen that if this array of 10 elements try to work with something outside its bounds, out of bound exception is triggered. And normally the arrays are quite well documented by their names. One reason names are long, explain everything, plus they can't be by mistake introduced in the scope with your variables. You name a variable array index out of bound exception, this is most unlikely. Because arrays are references, when you assign an array to another array, you are working with pointers behind the scene. So copying, which means deep copying, it's a different story. Right, so be aware, and we will see this approach for most types. If you have an array variable A1 pointing to this array of integers, and then you have A2 pointing to this array of integers. If you say A2 is assigned the value A1, what happens? This goes here, because what you do, you work with references. It's no problem with memory leak because this is handled by the garbage collector, but you might not want to have this situation. All you might want is to have A1, which was, let's say, 4 elements, and A2 with 3. You want to do copying. This element goes there, this element goes here, and you want an extra data to do copying. So this is what we have for deep copying in C++, right? 1, 2, 3, 4. We want to end up with 1, 2, 3, 4 with the same elements. So to perform deep copying, the programming language, the Java programming provides this method, array copy. So be aware, this is a method in the system class, as you can see, in the system class. To make this method available to any program, you don't have to include anything. So you just have to know how to use it. You can copy arrays of the same size. This is one thing you have to be aware. And you provide 5 arguments. Where to copy from, starting with what location, where to put your element, at what location in the array, and how many elements. It's preferable to have arrays of the same size or different size, but then you copy the number which is smaller, because if you have different sizes here, things can not work as you might guess. So we talked about variables, and we have seen that there are 2 big types, primitive and references. Parameters in Java are always passed by value, as I mentioned, but the behavior is depending on the type of the parameters, primitive or references. Strings and arrays are objects, and they work in specific ways. don't know whether, okay, slide. I have a slide about an interesting issue going on with Java at the moment, and Oracle and Google. But first, today we will cover input and output, and we'll talk briefly at the end of exceptions. So, I don't know whether you have heard that there is a big court case in the United States where Oracle has claimed that Google used Java, which is open source, free software, but Google used Java in its Android, and Oracle claims something like $8 billion damage from Google. They are in fighting mode since 2016. They are going back and forth, and apparently March 27, it was some discussion, some ruling that Google didn't owe Oracle anything, but then appeal took place, and there is still going on. As you can see, there are big issues in tech industry. This is not the only big court case. Google had problems with Samsung, I think, Apple had another court case with Samsung because it claimed that Samsung imitated some design which was used by Apple for its iPhone. So there is a lot of things about copyright issues. Copyright is a big thing in the tech industry. That's why we have a lot of new laws coming into place to try to cover things. Now, Java APIs are free software, so you expect them to be available to everyone. So Google, when they used it in Android, did not infringe any copyright, but then apparently there is some small letter rules saying if you get money from your software you create with this free software, and if you get a lot of money, then you have to pay something. Anyway, Google and Oracle are fighting over Java copyright. So this is something where it's good to know. Probably you have seen that there were some other issues, software in Volkswagen case. Anyway, now for input-output in 1998, I was tutoring for Auckland University, which used to teach Java for introductory course, stage 1 course. And it was one of the first year when Java was used by academia. All the books we have used did not come with input facilities, because Java initially was used extensively for internet, and providing input in your programs via web pages was dangerous. Could access your computer, introduce bugs, introduced viruses and stuff like that. So most input-output was performed through drop boxes, drop-down lists, and you click something from there, and this was the way to perform input. So what happened in the lectures, lecturers come up with some method, some function, some class to perform input-output, and then after 1 month we discovered that it was wrong, we have to fix it anyway. And in 20 years, right, in the last 10 years, I think after Java 5, they decided that they have to have good input-output. But they are still working on this because they try to maintain the old code working plus the new facility introduced in the language. We will briefly look at main two issues: how to work with input-output from standard devices and how to work with files, and try to compare with the approach in C++. Of course, you have to perform output. For your assignment, I think you don't have to perform input. But you will see there are easy to use facilities and not so easy to use facilities. All input-output in Java is provided by Java I/O. You don't have to include it in your files, except if you start working with files to perform input-output from files. But for standard processing, for input-output from standard devices, the facilities are there for you to use directly. And everything is performed via data streams. So via streams, the same metaphor as in C++ is used in Java for performing input-output from standard devices or file system. And they introduced a feature which we'll not touch, but the way this serialization worked was if you have a class with a code, you run the code and then you get the object file and stuff like that, and then it was converted to binary and you can store that file somewhere. So later on you can send it to someone which might need to recreate your file. And this was considered serialization, but from the latest version, I think they are planning to drop it, so we don't talk about this. And we will briefly touch on exceptions. These are good places to try to clarify issues if you need to use something and you don't have enough information from this lecture. As you know, a stream is an ordered sequence of bytes. This is something which is an abstract thing, right? Normally, it doesn't have a fixed length. And now this abstract idea is converted into code through various groups of data, you will see. We can have reading data or output data, write data. So we have a tree for input-output, so I won't go to the website, but if you want to find out more information about what I am going to talk here, that is a page where you have to go, which is the one on the previous slide 4. Now, that input-output package provides an object, predefined object, called system.in, and this is what you know from C++, C, in other words, associated to the keyboard, standard input device. Now, system out is associated to the screen, and system error is associated to the screen to display errors. And the equivalent in C programming language and C++ programming language. Now, you will see that to perform input, no matter that we have an input buffer stream or input file stream or other types of streams, we normally have read information with next byte or number of bytes, and similar write a byte, which is a byte is an int, one conversion which has been set up, or write an array of bytes. So all reading is containing somewhere this keyword read. All writing is containing somewhere in the name this write. And then, of course, close to say that, okay, now the stream can be closed. In other words, if we are working with files, a file can be stored, and we have done working with this. So close is linked with some action behind the scene, which if you don't perform, you might get in trouble, because you might, for example, open a file for reading and then you want to close it and open it again for writing. It's possible. But if you don't close it, you can't continue. And notice that flashing is only for output stream define. And there are many other methods, but we don't. Now, this is the first type of stream, buffered input stream and buffered output stream. They are storing in a place in the memory, buffered code, operations which are going to be performed in order to speed up the performing. So this is buffered, means it has an intermediate place to store data. Input stream and the data output stream works with Java primitive types in principle. Java primitive types and allows to convert to the machine operating system. And then the third one, the third group, input stream readers, output stream readers, which, as you can see, act as a bridge between byte streams and character streams. There is a very complex mechanism to perform input data, as you probably guess. So this type of streams read bytes and convert to different type of characters. We have Latin set of characters, we have extend Unicode, we have 16 bytes code, 32 bytes code for characters, and nowadays they have introduced it in C++ as well. Things become more complicated because they try to accommodate as many people as possible. Again, input, we have a read data, as I mentioned before. So in order to use these types, you have to read a little bit the documentation. And if you go to Java stream hierarchy, it's the first time when we look at some classes in Java stream. you can access this documentation from Oracle website. You will see that all objects in Java are derived from, all classes in Java are derived from one class called object. Everything, even your classes, are derived implicitly from an object. And then in the Java package, there are these files, these classes, as you can see: input stream, output stream, reader, writer. They are abstract classes, some of them. And then we have a file stream. After that, from the input stream, we have derived classes, which repeats here: byte array, input or output, file, input, output, filter, object, project. So these are, you can see, paralleled for input and output. And then we have buffered data. And from this we have other derived classes. So notice how the documentation is presented. Data output stream is derived from file output stream, which is derived from output stream, which is derived from object. And probably you notice that each class is having only one parent and a parent only in the end. There is possible to have, we will see, abstract type classes to have more than one. But for this hierarchy, as you can see, there are at least 3 levels of inheritance, and with the object, which is abstract class, it's the 4th level. And each class comes with own constructor, and when you declare an object of file reader or file writer, all constructors were called, and the Java was very slow. But now they have moved many classes to be abstracted. The speed up was improved. The simplest way to perform input and output, to perform input from stream, is to use a type which was introduced with the latest version of Java called scanner. Scanner is a class which can read integers, strings, and has very simple syntax. And here we have an example of this. In order to access scanner, you need to import Java utility scanner. And my example is called class add. Notice Java name, add as well. And you can see that in order to use that type, you have to declare an object of this type. And because we wanted to read data from the keyboard, you have to pass this to the constructor, system in. And after that, you can read integers with the method nextInt, and this method returns hopefully an integer which was entered from the keyboard. You can read some, we will see next one. You can read float values, but you have to say next float. You can read strings just with next. So there are very simple methods to be used. In this example, what we do, we read 2 integers. We declare an array of doubles. Notice that we haven't used new, but we have used initialization straight away. So you can say that for arrays and strings, there is this shortcut to declare variables. It's a shortcut. only for arrays and strings, nothing else. And then, as you can see, we use a variable to store whatever values are here, edit the total of them. Recognize the for ranges we have seen in C++. It's exactly the same syntax. We go through each element in here. So first this will be set up to math random. As you can see, math is a class which provides mathematical tools, and because the method is invoked on math, you can guess that this is a static member of the math class. It's a public static member. It's a method which is called on the class itself. Yeah. So this method returns random values of float, double type, real numbers. And we have 1, 2, 3, 4, and then we have another class method, square root, which computes the square root of 1.2 as the last element in the array. So with this first gets this value, its sum is updated, and then val gets the second value, sum is updated, and so on and so forth. And then we compute the sum is, which is this value, sorry. So first number 35, next number -5, sum is 30, comes from here. Right. Notice the brackets. They are needed there. And then with this, I took out this comment, but if you want to type it, you can find out what were the values here, what is the value. All I printed is this sum, which is a double value, extended precision. Right, scanner. It comes with these lovely methods. Has next, returns true and false. You can check, is something to be read in the pipeline? Returns true if the scanner has another token waiting to be assigned. You can use it with no arguments or pass in a regular expression, which is given by the pattern. And if you are teaching, if you are enrolled in internet programming, you will learn a little bit about this. It's a way to check that some expressions are valid email types and valid websites, and make sure that there are no viruses passed in. We don't spend time, but at stage 3, you might talk about this issue. So, has next integer, has next double, all are for checking that there is data to be stored in cases you expect input and you are not sure that that input is of the proper type. Read the next token, which is returned like a string. Notice, whatever is there is returned as a string if you read it. And it comes overloaded. Then next int, we expect an integer, we expect a double. So very simple to use this to read the data from input, from the standard input. And here we have a more extended example. Again, we design an object of scanner type, and then We use it inside main. Now in Java, inside main, which is a static method, you can use static objects. So if you take out static and say public, probably it will work, but if you leave it with no specification, it might ask you to make it static. And as you can see here, we read strings, integer, and double. String, string, integer, and double. And then we just display them in some form to check that what the reading was perform. Now, in order to work with output stream writer and input stream reader, you also have to work with objects. You have to declare the objects, and you have to pass some argument to the constructor as before. And then, as you can see, to display data on the standard output, we use write method and use flash to force the output to appear. For reader, it's because this is read as a byte and you want to store it in a character, you have to force the system to convert it to a character. As you can see here, whenever you invoke read, you have to convert it to either character, int, or float. So it's not as easy to use as a scanner, but it has less data, less methods to use. After using them, you have to close them, and maybe if the input-output was not possible to perform, some part to deal with possible weird situation. Files is just to make you aware that there are two steps for working with files in Java. Again, it comes with methods. You have to read a little bit. Java deals with directories, which are, folders in other way, through the file system. Like Python also has this approach. So in one way, if you know how to work with files, you can work quite easily with directories. Again, for files, we have lots of information. When the file was modified, how many characters are there, can you delete it? If yes, it returns true. If you can't delete it, it returns false. Be aware, Java is still used for concurrent programming. So it comes with a lot of facilities which are used in multiple threads working. But in this case, the file is a normal file or it's not a file, it's a folder. So you have checks. And then how to work with path for your files or directory. What I would say it's somehow important to notice is that in order to work with files, you have, first of all, to declare objects of file type, output or input, because these are used by the file output stream or file input stream. So there are two steps when working with files in Java. One is create the file which creates a variable to link it to the disk file. This is a file stored on the computer. Okay, so after this linked handle is created, then we need to have access to perform output or input, and all these input-output tasks are provided by the types file output stream and file input stream. So that file is passed to the constructor, and we create a reference which can be used for write for the first output and read for the second output. But we won't go into details, just to let you know 2 steps. I think the similar two-step process was in C, if you remember. Now, exceptions, everything which is an error is treated as exception in Java. And input-output is a very common place when you get exceptions. The file was not found, the entry point was not found. So, some people use exception to perform some tasks behind the scenes, which is not a good approach. This is the last sentence about. They should be used just to deal with errors which might happen at the runtime. Like in C++, we have 2 keywords, try and catch. Throw is also used to throw exceptions. But on top of these 2 words, try catch, every block having try will have to include an extra block for finally, which is always executed. So C++ also started to move to this direction. This finally is there to guarantee that the system is left in good state. Closing file, recovering memory which was allocated. This happens in the finally block. So each try statement can be followed by at least 1 or more catch statements. And this is an example which is chopped from my example. And I will update the example. Correct one is here. Okay, so this is a file, and it was meant to be like this. Simple except you don't need to include, this is included in the latest version of Java compiler, the name of the class, okay? And then we have just a single main. And in the try block, I have provided some division because I want to trigger arithmetic exception. This division, 46 by 5, it's okay, so it won't trigger any arithmetic exception, but I will change it when I will run. Now, if the division is correct, this is displayed. Then, as you can see here, we declare an integer of 2 arrays elements, and I try to access the 3rd one. Definitely this triggers an exception, and from here we jump here. Array index out of bound exception is executed. After this message is displayed, we jump here. We are in the final block. So this is executed always, and then we are at the end, and out of the try catch is executed. Okay, so I will run this. As you can see, final state of first rate for First statement of try block, 46 divided by 5, yes, it's 9. And then when we try to access A3, exception thrown. So we are at array index exception thrown, and as you can see, when you invoke array index out of exception, you can have that E message, E object there, which tells you something about when the exception occurred because of this number. This is how, index 3, this is how the exception for array outbound is done. After execution of this, okay, we are here, we are in the final block, right? And then we are outside. Now, if we try to use this to 0, and then you compile it, and then you run it. First statement in try, we are here. We perform division by 0. This is an arithmetic expression. So, arithmetic expression, arithmetic exception by 0, you get very good information, final and out. So this is how C++ exception works, except that finally is not there. I will update this, I will put this in your file, your string, and I think we are almost there, sorry, again. So, there are a lot of exceptions. They are defined with inheritance, end of file, which deals with situations when you work with files, file not found, interrupted input-output exception. This is when things are worked through threads. So, exception, it has a very good page where you can go and learn more. Very nice, organized. We didn't talk about unchecked exceptions, but we talked about catch, what is an exception, advantages. What is very important to notice, each lesson comes with question and exercises. So you might want to go into these tutorials and try to see whether variables and other things about Java, when we talk about classes, those exercises might help you to clarify your thinking. We talked about input-output. It's an extensive area. We won't cover in file, working with files for this, but you should have a rough idea. And the documentation for Java 8 is here. Next, we'll start talking about object-oriented programming in Java. Thank you for coming, and tomorrow it's a lab time, and on Monday we will have lecture time. Any question? So we have 3 lectures for Java next week, and last week we have design patterns, review for what we have covered, and exam preview, and then last lecture on Thursday. There is no tutorial in last week of lectures. Thank you. See you.
Thank you.
Don't have questions.